Thank you, Mike.
All right, best of luck, and back to you guys in the studio.
We're going to head things over now, though, to the Analyst Corner with Mitch. It's Mitchell Ashley, CEO, founder of Accelerated Strategies Group. And Mitchell's talking today about real-time systems and data analytics in a specialty domain, and that is critical for a strategic area for many businesses. It's the importance of real-time streaming analytics. And Mitchell's conversation is with Bill Bain, CEO of Scale Out.
Welcome to Analyst Corner. Mitch Ashley, CEO with Accelerated Strategies Group. I have a really fascinating conversation coming up in our next video segment that I want to do a little bit of a lead into. Now, occasionally, I've been around for a while and working in a lot of different parts of IT and technology and our world. But of course, there's many areas I also haven't spent much time, and one of those is in real-time systems. Just not something that I have a great deal of expertise in, nor my career led me into in much at all. So it's always fascinating for me to learn in a domain that I don't have a lot of experience in, or certainly have a lot of gaps in. And maybe that's the most important thing to recognize when you don't know something. And, I always consider that. And when I don't know the answer, that means I probably have an opportunity to learn something. So I certainly learned a lot from this conversation. Now, the guest that I have today, his name is Dr. William Baines. He's CEO of Scale Out Software. He goes by Bill in our conversation. He'd reached out to talk with me about some interesting things our company is doing. And they have something going on sort of in the COVID world, but that's not really their main focus. Bill's background is that he came out of the Intel supercomputing group, went to Microsoft, and has been working on this distributed caching, in-memory data storage and processing for very large real-time systems. So imagine whether it's sensors at a toll booth or IoT sensors for that matter in a home, could be security applications, could be a health application like a COVID, contact tracing kind of situation. But he's really been working on this problem for quite a while. Bill is what I would call a true data scientist or computer scientist, really, very involved in the science and art of it, but the advancement of it. And so super interesting person to talk to. And I really enjoyed our conversation today. He brings us into this world of something called real-time streaming analytics. So imagine doing analytics. Now, this is not post facto, let me go look at the data that's, kind of data exhaust that's thrown off from a real-time system. This is looking at what's happening now and then doing that in some intelligent way where you can make sense of it. I mean, in a large real-time system, things are happening, of course, at such a rate. No human can do much with that large amount of data, just on an exception or on an individual basis. So his company has developed some really interesting technology, and he introduced me to the topic. I wasn't familiar with it, of something called digital twins. So his technology is around real-time streaming analytics with digital twins. Now, that wasn't a familiar concept to me. He discusses some of the origins of it. And it's just very interesting. And we talk about some different applications of it. I was really fascinated by his thoughts on, what does the world look like when we have so much, take where we are today. And it's just that the rate of advancement, the rate of accumulation, the rate of capture of all this information, real-time information, where are we going to be in the future? How are we going to operate in a world with so much data so fast in the moment? No one can deal with it, even with really good analytics. And he introduced the thought of what analytics can do in that kind of environment is simplify some of the complexity. And I thought that was an interesting paradigm because there's so much of oftentimes what we do in the technology world is really, there's a lot of complexity in it, but ultimately it's about delivering an extremely good customer experience. Well, anything that's looks simple is probably really hard. That's been my experience. That great user experience that happens in an app or on a web application, whatever it might be. The effort that goes into that is phenomenal. It's sometimes staggering how hard it is to make something simple and really usable. And in a world where we could easily today get overrun by the volumes, quantity, the analysis, the meaning, the integrating it with third-party or external data to provide context. So much of that we couldn't do ourselves in real time. And as you just layer more and more of that on top of it, Bill's point, I think, in the discussion was how that can help us bring some understanding to that increasing complexity. So I want to turn it over to the video with Bill, and I love your thoughts on it. If you want to reach out to me and share your thoughts and ideas, you can always reach me at mitchell@accelst.com, and enjoy. I think you'll find it insightful.
CISO Talk, to hear how real-world CISOs are dealing with today's real-world issues. From enabling secure remote workers to accelerating secure cloud adoption, defending against a pandemic of security attacks and beyond, CISO Talk covers the cyber topics you want to learn about. With your hosts, Unisys CISO Matt Newfield and MediaOps CEO Alan Schimmel, featuring a revolving panel of CISO cyber experts. This is where CISOs talk. Join us on digitalanarchist.com and TechStrong TV.
This is Digital Anarchist.
I'm joined by Bill Bain, who is CEO of Scale Out Software, talking about a really interesting topic I know a little bit of and some I don't know about. So first, before we get to that, welcome, Bill. Good to be talking with you.
Thank you. I really appreciate the opportunity.
You bet. Now, Scale Out Software is in Bellevue. I guess you have locations in Beaverton, maybe an office in Denver, not too far from me. You've been around since 2003. Does that sound right?
Yep. Been around a long time. I came out of Microsoft and started this company in Bellevue, right next door to Microsoft in Redmond. And we've been developing software and had products on the market since 2005.
Okay, great. Now, I think you started in the distributed caching, kind of in-memory data storage, that part of the business of the industry?
That's right. Yes, back in 2005, there was no, believe it or not, there was no really good distributed caching solution for the .NET world, for the Microsoft world. There were some Java products. And so we filled that gap by introducing a product for .NET and also another for Java. And that product has been in constant use since 2005. Some really large companies use it for holding things like airline reservations and shopping carts for e-commerce sites and a variety of other uses.
Yeah, I would imagine applications that are very high volume, don't have time for disk I/O, that kind of thing, are prime candidates for this kind of technology.
Exactly, right. Yes. In fact, because it can scale so transparently by just adding servers, commodity servers, it can handle really large workloads without having the response time get longer and longer. And that's what you really need, say, for a big e-commerce site. You want to make sure that customers and shoppers always have very fast response times. And the same applies in other areas like financial services and airlines and logistics and many other applications.
I'm sure you've evolved this into the cloud world, into Azure, maybe other environments. What's different about the cloud world when you're talking about distributed caching or in-memory kind of analytics?
Well, we haven't introduced our product in the cloud world yet, although it does run. You can use it in AWS and Azure as you stand up your own distributed cache. But making it software as a service where all you do is sign up and it's just there is a bit more challenging for a variety of reasons. But what we have done is introduce a streaming analytics service for Microsoft Azure, and that runs so that all you have to do is connect to their IoT hub or to other sources and receive incoming messages and telemetry from devices, and we can analyze that with our in-memory data grid behind the scenes, and then provide analytics, feedback, and also visualization, all built into one product.
Okay, interesting. So kind of give us the flow. You're talking about, in-memory shopping carts and applications that have in-memory data. That's feeding into an analytics engine That's all happening in real time. So you're feeding this into an analytics engine of which you've configured to answer or provide data about some particular questions or algorithms, correct? Am I following?
Right. So distributed caching is really sort of the underpinning of an in-memory computing system because it provides you in-memory data storage. And what it's doing is hosting millions, thousands or millions of objects, software objects in memory and distributing them transparently across a grid which is just really a cluster of commodity servers or virtual servers in the cloud. And that gives you very fast data storage and high availability through data replication and there are many other technologies under the floor that are employed. For example, peer-to-peer membership, and we could go on and have a whole computer science discussion. But on top of that, then what you want to be able to do is two things. One is data parallel computing. So you can look at all those objects at once and extract value from what's in them. So if it's shopping carts, for example, you might want to know what are the most popular products selling this hour. Maybe I want to do a flash sale. Maybe I want to put a product on a special, give it a special price. Maybe I want to identify particular users or shoppers and make them special sales based on their shopping history. And so what happens is data parallel computing lets you see the big picture, gives you what we call situational awareness about the state of your live operational system. And then the next step after that is to incorporate stream processing so you can focus on each individual data source, whether it's an e-commerce shopper or an airline traveler or a person doing a banking transaction or a person wearing a smartwatch and sending telemetry to the cloud. You want to be able to look at each individual data source and try to understand what the incoming messages and telemetry are telling you so that you can respond in a focused way to each individual data source, in addition to doing aggregate analytics across all of them. That's a lot to take in at once, but that's what in-memory computing lets you do.
It is, and then what I'm thinking about is at very high volumes, how do you respond to something that's happening that quickly, maybe across a large grid of kind of data sources? I mean, how do you do that, or do you have to do that at a more macro level?
Well, that's a great question because typically what you find in streaming analytics is that the software platforms tend to look at the incoming data at a macro level. They look at typically as a pipeline or a stream of incoming messages from all the data sources, and they look into that stream to try to extract value. So for example, if it's a stock prices flowing by, you want to see which companies are having their stock is going up quickly or which ones are taking a dive, and be able to then signal somebody to make a stock trade. That's an example. Or if you're looking at cars flowing through tolling booths on a highway system, you want to see where is the congestion starting to occur? Where what do we need to do? Maybe we need more employees at a given tolling site. Those are just some examples. But what you really, really want to do is be able to handle each data source independently, ideally, so that you can keep information about that data source that allows you to understand what the telemetry from it is saying. So in the case of the stock trading, if, say, pick your favorite high-tech, company that's stock price is going up, you want to know, well, why is it going up? What is in the news today? What's happening to the executive personnel? Is somebody being hired that is a luminary, or is somebody being fired? So you'd want to be able to make a stock trading decision based on some insights you have about that stock, not just what the stock price is doing. And that would apply for healthcare tracking too. If you're looking at telemetry from a smartwatch and it's telling you blood pressure and blood oxygen and heart rate, you want to know, well, what does that mean for me versus say for you in terms of my medical history and current medications and activity. So being able to give focused feedback or take focused action for each data source, that's a big challenge that streaming analytics has not really handled very well until now. And so we have introduced a new technology to address that challenge.
Okay. Well, I'd love to hear more about that. One of the things I took, though, from what you said is it's not just the streaming data and the analytics of that. It's matching up to third-party or external sources to put context or more meaning around what that data is bringing to you. Is that correct?
Yes, you're actually pulling in data from the outside, and that's these cloud services like Microsoft Azure have hubs for allowing you to pull in telemetry, and then also called IoT Hub, it lets you pull in messages from data sources. You also can just go directly extract data from databases and other third-party sources that allow you to enrich your understanding of what the telemetry is telling you. The problem with all of this is there's no good software model for managing it, and it can be intractable if you just sit down with pencil and paper and try to cobble together a solution using typical approaches with databases, web services, data lakes, and so forth. That gets very complicated fast. To give you an example, suppose you're tracking a fleet of trucks and you want to track each truck and you want to know things like, has that driver driven too long? Is that driver driving erratically? Does the driver appear to be lost? Is that engine telemetry telling me there's going to be a problem occurring, or is it just normal for that particular truck? So you want to be able to do that, say, for 7,000 trucks and do it simultaneously and respond within a few seconds. That's where the software modeling techniques we use in typical streaming analytics, and I'm talking about open source technologies like Apache Storm and Flink and Beam, they are challenged in solving that particular problem. And so what we have done is apply a new approach called digital twins, which have been around for a long time, but not been applied to this problem. We're applying that to this problem in order to allow you to have this ability to track individual data sources and respond in milliseconds to them.
Digital twins is not a term I was familiar with. Tell us a little bit about what that means. I think you said it comes out of the manufacturing world, correct?
Yeah, it comes out of a technology area called product lifecycle management, PLM, and it's been popularized for simulation and for modeling devices that are put out in the field and then tracked to see how they're actually performing, like motors and valves and so forth. So it's used heavily in IoT. People typically think of digital twins as being used in simulation, although it is also used in managing, as I said, the life cycle of a device. So you can see whether or not it's performing up to spec and whether the next generation needs to be improved. Now, more recently, digital twins has been applied to things, business process modeling. So, for example, using digital twins to model light switches and doors and in buildings and actually the floors in the rooms in a hierarchical manner, so that you can have a model of an office building and know at an instant which light switches are on and how to turn them off, and use a digital twin approach to that in a hierarchy. But applying it to streaming analytics, where you're looking at incoming telemetry and trying to respond quickly, that's a challenge that we're applying digital twins to. And so we put this prefix, real-time digital twins, to describe them as somewhat different than the traditional use case.
So talk to us a little bit more about, I want to go into more depth about what is it about real-time data, real-time analytics, and doing digital twins? Why is that a particular hard challenge that hadn't really been solved up to this point?
Well, if you think about how do you write software that's going to track the state of thousands, maybe a million data sources. And so, we've just done this demonstration application of contact tracing, which we could talk more about how digital twins can help solve that problem. The challenge you have is you need to maintain state information for every data source. Okay. And typical streaming platforms don't have a first-class mechanism for doing that. They leave it to the application to figure out how to do it.
Yeah, they don't touch state at all. That's part of how they handle such high volumes.
Right. They just watch. They typically are thinking in terms of either a directed graph or a pipeline, or just a straight-in pipeline of messages in which you look into and extract value. And often what you're really doing using the so-called Lambda model of stream processing is you're doing a very limited amount of work in real time, and you're really just filtering data out and pushing other data into a data lake, so that offline in a data lake, you can analyze it with tools like Spark to find the big picture trends using, the aggregate analytics, the operators like MapReduce in the data lake. So people typically punt on the problem of doing aggregate analytics in real time. And they also don't have the tools to track the state of every individual data source and couple that state with the telemetry as it comes in. And if you think about it, that's where in-memory computing has a particular strength, because it's storing all of these objects in memory and it has transparent scalability. If you can just get messages to the objects, you can very easily find the state about a data source that you need to analyze that incoming message. And so that's what gives rise to using a digital twin approach. Because a digital twin, just all it does is allow you to associate state with incoming messages from that data source, and it allows an application developer to write a little piece of code that says, oh, I have access to the state, I have a message, I will now analyze in some domain-specific way what's going on and send alerts, go write to a database or read a database, do whatever I have to do in a standard language like Java or C#. So it's a very nice, simple, well-understood object-oriented approach to solving that problem.
Interesting. I'm curious too, is that kind of maintaining that information about state, does that mean you're only aware of what the current state is? You're not maintaining any history of it? And that's for a more traditional data storage source?
Well, that's a great question. And the answer is no. In fact, the object, which corresponds to that data source, maintains the state that's needed to do introspection, so it can look back. It can keep time-windowed lists of incoming messages, or typically what an application will do is filter the direct incoming messages and create its own list of messages that represent significant events that have occurred. So, for example, if you're watching temperature coming from a wind turbine, the temperature in the turbine itself, say the oil temperature, and this is not actually done. People, I have learned, do this on site. It's done with edge computing. But just to give you the picture here, if we're looking at temperature fluctuations, then you would say, well, I don't really care as long as it's in the normal range and it's not changing plus or minus. But if I start to see an excursion upwards, that's an event. I'll record that event in a time-ordered list. And then if that occurs again, I'll say maybe there's a pattern here. So you can write a predictive analytics algorithm for that device by recording a history of what you consider significant. Now, at some point you say, well, I want to keep I want to keep an archive of all these events that I've recorded. So the digital twin code can just push stuff out to a time series database or to a standard database or a blob store. There's no constraint on what it can do in terms of accessing external stores. But in terms of what's kept in memory, it's the state that's relevant to doing the analytics you're trying to accomplish.
That was part of why I asked that question, because it seemed like managing multiple states of state could be a real challenge in terms of consuming memory. But you talked about how that could be then pushed off into more traditional data storage.
Right.
Interesting. So I'm curious, you mentioned this demonstration application. Tell us more about that.
Okay, yeah, sure. So we started looking at the use of real-time digital twins for contact tracing. And what we recognize is that it's, the solutions that are out for the public to use are difficult. They're complex. I just saw a news story yesterday about how using people to do contact tracing is highly frustrating because people won't answer the phone. They won't. And when they do answer the phone, they won't tell you what you need to know about who they've been seeing because so there are all of these problems with.
In the world of HIPAA, let's share our contract tracing information with you, right? Right.
And then when you look at these Bluetooth-oriented, apps for mobile devices, well, they have their challenges because people worried about their privacy. However, if you think about companies, they have a kind of a narrower problem because you have a restricted population, which is already broken up into departments and groups, and you understand which employees tend to interact heavily, and you also will know when employees go interact with other groups. And so you can actually model these interactions using digital twins, where you have one digital twin per employee. And in that digital twin, you keep track of all of the contacts that were made within a reasonable period of time, like 2 weeks, so that if, in fact, any one employee tests positive, you can immediately traverse the network of intermediate contacts and find all of the employees who could potentially have been affected and notify them immediately within a few seconds. And at the same time, you can do aggregate analytics to see what's going on and whether you've got a problem in a particular state, in a particular department that you need to go address.
So that means, can imagine certainly people coming in and out of a building, but also if you're doing geo-tracking, geo-fencing, things like that, now you really could potentially say these two people were within proximity of each other for this period of time.
Yeah, you can do that. What we have demonstrated is something simpler. We wrote a mobile app, and let it connect into a digital twin. So an employee would be in this, hypothetical usage. This is a demonstration app, as I mentioned, but the mobile app, which is fully functional, will let an employee notify when that employee, say, goes to a meeting in another group. So automatically the digital twin, the first thing it does for that employee is ingest the group members from the employee database. That's a case of going out to a corporate database. And so it knows, okay, if this person is going to work, then they're going to interact with the 10 or 12 people in their group. And if any one of them gets COVID or tests positive, then all of them need to be isolated. That's a given. So that can be fully automated. The second thing is, though, the employee can say, okay, I just met with Joe over in that department somewhere else, maybe a different site, and that will be pushed to the digital twin and kept as a record, so that for 2 weeks, if anybody that Joe interacts with or that is tested positive, then this employee will be notified through the mobile app, and vice versa. If this employee tests positive, then it will tell Joe through Joe's digital twin, and then all of Joe's contacts in his network will also be notified.
Okay, good, very good. I'm curious, and thanks for telling us about the demonstration application. Have you gotten any interest in, hey, we'd like to actually do more with that, or this is really more kind of you're focusing on your technology and not promoting it for its potential uses?
Well, it's interesting you should ask that, because it started when our salespeople were talking about the digital twin service, and I had written a blog which just, in a very general sense, talked about contact tracing, and then one of these large customers for our company said, we'd be interested in learning more about that and how that would actually work and how we could employ it. So we built this demonstration app to show them. We have a load generator, so we can generate the load for a 30,000 person company and also inject statistics about the current positive rate that we're seeing today, and change those statistics. And then you can see when these random contacts are made based on a statistical model, how the interactions cause positive testing or the need for isolation throughout the company. And this can be visualized with aggregate analytics. So one of the benefits of this digital twin approach is that you get the aggregate analytics almost for free. And the reason for that is the state that's in the digital twin can just be brought into an analytics engine and immediately processed. So we do that with our product, our digital twin cloud service, and we visualize in the results. So for example, if you see that an employee tests positive, then the bar charts can show you, well, which sites and which departments at those sites are starting to have an uptick in the number of positive notifications. And you can also ask the question, how many intermediate contacts are we seeing on average? So you get a sense of how widely employees are interacting across the company. All of that information helps managers to control outbreaks and keep people isolated when necessary. Mm-hmm. I think the key to managing the return to work is to catch outbreaks quickly and manage them quickly. And that's what this kind of technology lets you do.
I think you could say that about a number of things, whether it be sporting events and, team events and all kinds of places where we interact with people that we're now separated from, or at least partially.
Yes. So, that's what having this be real time. I mean, if you think about how else you would do it, I get the question a lot, not to interrupt your question there.
No, go ahead.
I get the question a lot, why can't I just do this in a database? And the answer is, yeah, you could. Some things you can't. If you need sub-second response time, you probably can't. But for things that 1 to 10 seconds, you probably could do it with a database. However, you end up building a very complex solution. You have to implement a web service that implements the moral equivalent of digital twins without, it's not structured that way formally, but you end up having to have a web service that has a distributed cache managing state, cobble it all together, connect that to a database for long-term storage. You have to then connect that to a data lake and do analytics, connect that to a visualization tool set, and then visualize it. By the time you put all these pieces together and get all of the different skills going, it can be weeks or months. Whereas a digital twin application can be written in a couple of days, and it can be changed within an hour. So if you need new statistics, you want to start tracking something new, you can do it immediately.
Well, the phrase "moral equivalent of digital twins" is not a phrase I was anticipating hearing anytime soon. Or that's one of those unknown unknowns. But no, that's really fascinating. I'm curious about thinking of, in addition to the COVID situation and health and things like that. There's been so much acceleration of digital strategies and digital applications, and companies have rapidly shifted a lot of investment to that. I mean, some people say, we've done in the last 5 months, 6 years worth of acceleration into investment in digital technologies for applications. Given the world of sensors and IoT, there are so many, vastly growing sources for all of this data. What if you had to kind of extrapolate and think out loud, what do you think are some of the applications that are either coming sooner now because of the acceleration of digital experiences, or just in the sheer volume and different ways that we're collecting all this data? I'm really curious of your thoughts of what's going to be happening in our world.
Well, I think intelligent devices are going to, the use of them will accelerate. And, if you can manage what you're learning from them and respond effectively to them, then I think they will proliferate. I think there are a lot of uses which are kind of just hobby uses. A lot of the stuff we see in the smart home and so forth is not particularly high leverage. But in smart cities, I think you're seeing a lot of high leverage use of smart devices. For example, to protect schools from attacks. We saw at the Azure IoT show in February a company which is actually notifying. They have sensors on light posts that on traffic signals that are listening for sounds, and if they hear a sound like a gunshot, for example, or in a school, or the doors are not being operated in the way that is expected, you can notify agencies to respond quickly. So I'd say that with the 5G networking, so you have a lot more bandwidth, a lot more ability to ship telemetry up to the cloud, and with deeper introspection. Also combining that with machine learning, that's another thing we haven't talked about, but digital twins can use machine learning to listen to the telemetry and analyze it and respond to it. I think we're going to see a real proliferation of the use of smart devices. But another case is, in the world we're looking at, is also for helping people, not just shoppers. The conventional way people have done shopping with getting recommendations, which are just trying to help them buy more. But using this kind of approach for streaming analytics will allow shoppers to find the products they're actually looking for more efficiently. And also, this is another area we're looking at, is applying it to airline travelers when people start flying again, just as an example, where you can help a person get through their itinerary with handling weather delays and equipment problems and all of the issues that we run into now, where, if you're flying cross country and you have a connection, odds are it's not going to end up the way you think it did in terms of delays.
Don't have those connections. They never work out good.
and yet you're having to respond in when you land and do things which are suboptimal. But if you had, if the software systems are more intelligent about each individual passenger, not just the high value passengers, to be able to offer them opportunities to reroute while they're in flight, and let them know, okay, we're going to have a problem, but here's some alternatives, and get it all set so you have, in those hours you're sitting there on the plane, be able to figure out what you're actually going to do about it and plan it all out. These are some applications that I think will add value to enriching people's lives. Another one, just real quick, that comes to mind with all the fires we're having out here right now in the West, is disaster recovery. So, being able to have intelligent sensors on not only power poles, but all throughout a forest or a community next to a forest, so you can understand when fires are occurring more quickly and how they're moving, so that emergency equipment can be directed more effectively to both to rescue people and to put out the fire. Having a lot more intelligence in the networks is something that this kind of technology can assist with. And I think we're going to need that.
It sounds like, too, part of what you're saying is, as the complexity rises, because of both the volume and all the interdependencies that may exist or could be associated between all this data, at some point you can't manage all that yourself. You can barely manage your schedule and handle a delay through the airport, more or less. Is the fire going to be here? Is there a fire and it's going to be here in 20 minutes instead of 40? But that sounds like what you're saying is that this technology could help us better manage all our world and all this data that we're surrounded by.
Yes, because we are, in fact, we're billions of data sources producing messages. In some sense, we're rich with opportunity to assist in making our lives operate more smoothly by more intelligently tracking and managing and analyzing this information.
Okay, great. Well, this has been really fascinating. So folks that want to find out more about this with Scale Out Software, what is your website?
It's www.scaleoutsoftware.com.
That sounds good. Nice and easy. At least one thing was easy. All this data coming at us. So that's been really fascinating. And by the way, I like to be wrong, because usually when I'm wrong, that means I have an opportunity to learn something. So I appreciate you telling me, no, that wasn't the right answer.
Oh, no.
But it was really great talking with you. And I certainly learned a lot from it. And I'm sure our listeners, our watchers will too.
Well, I enjoyed it as well. And thank you so much. I appreciate it.
You bet. Keep us posted too. If the COVID application sort of has legs and takes off, that'd be great. Or other interesting. I'm really curious. As you kind of dealing with all this world of so much data, so much analysis in a real time fashion, as that tends to evolve. Keep us in the loop. Love to hear more from you.
Certainly will. Thank you. Will do.
You bet.
Okay.
So Bill Bain, CEO of Scale Out Software.
Join topic experts and peers for a Splunk virtual event. Observability to enable your digital initiatives. Are your apps and services distributed in the cloud, getting refactored as microservices, or becoming more complex? If they are, you must factor in observability. Observability is all your data to help you find unexpected failure conditions, explain why they happen, and resolve them fast. This event is about the challenges, opportunities, and best practices to successfully build observability into everything you develop, deliver, or monitor. Register today.
Hey, Mitch, thanks. That was a great interview. Good information there. Guys, thanks for sticking around here to the very end of it, folks. This is a great show. It's a great way to start off the week. We've got a really busy week here. We've got some great stuff. Remember, we're going to have a live interview Wednesday at 2:30 Eastern Time. Breaking news. Real excited by that. We'll be back tomorrow with our normal Tuesday show with also some great content. Operationalizing cloud-native software with Kubernetes. Check that out, as well as DevOps Experience, both coming up in October. Until tomorrow, though, this is Alan Schimmel from Media Ops, hoping you'll stay safe, stay well, stay strong, TechStrong. We're out.